Yeah, I'm just gonna warm up with this hard problem here. I believe, many years ago, they asked me this on an on-site interview at Amazon in Seattle. Because I remember like there's some rainwater thing, and yeah, let's dig into it. I don't quite remember what it is. Given n non-negative integers representing an elevation map where the width of each bar is 1. Go ahead and compute how much water it can trap after raining. I see. So if I'm dipping down and then I feel like this is DP. So if we start at, let's look at different intervals of this and see, like, let's say we started here and then this first 3 elements are irrelevant. Then we go 2, 1, 0, 1, 2, or 1, 3, and we trap, this much. So if I'm decreasing, I need to make sure that I eventually have something that's at my level or higher in order to have this water trapped. So assuming I can trap water, what is the area? So for example, let's say this index is I. So if this is I minus 1. So I minus 1. So this is 1. And then 2. So if this was 2, let's say, and then this I is more than 2, then it's like, until I reach a level higher than it, then I have nothing, right? So if I reach a level higher than it, then so I have a pointer that starts out at 0, and then boom, we have something that's higher than it already. So then perhaps instead of, like, we just update this pointer. And then because this thing here is 1. I want to start 0 instead of start 1. I could also say, like, if length height is, 1, return 0. That also works, I guess. Yeah. So actually, yeah, I is already here. I don't know why I wanted to instantiate that. So I is 0, and then this would be the same. So pointer is I, but then I goes to the next one, and I goes to the next one, and it's going to be higher than this height pointer, which is 0. So then pointer gets updated to 1. So originally I was gonna say something like else means is lower, then we can do like but there's a bug here. Originally this one would be like, well, pointer is here and my eye is here, so well the delta of these heights is gonna be, this. But we actually don't capture this value until we find something that is a wall. And the reason behind that is because if this array were to end here, the water would just spill over. Like, for example, here, we shouldn't actually add this value, like water trapped value. So, so this current water trap just says, well, which bucket are we in? And only when I find a elevation that is the same as the previous elevation do I capture this value. Let's just kind of run through if this works. So this is vacuous, pointer gets updated, and everything is 0, so it's 0. And then the next one, current water trapped, is gonna be this pointer is 0, height is 1, and then we have 1. And in the next cycle, or the next iteration, this height I is 2, and it is equal or greater than this one, so then this pointer gets updated to this guy, and then the water trapped gets this one, and then this gets reset. The next one is gonna be I is here, and then so this would be pointer minus I1, and then 2, and then 1, so 3, and then this will go here, and then this water trapped will be this 1 plus, the cumulative sum of this guy, and then our pointer gets updated here. This is tricky though, but if we go here, here, and here, if we go here, then I'll never actually see something that is like of this height, for example. Because then I do this, this, and this, this, and this, and then actually not count this guy. So how do we account for that? What if this guy was flattened here? Then what? Then we still do capture this one. And if this guy was here, we still captured this one, but then we still miss this one. Mm-hmm. Suppose you do this and then so if you have a maximum, let's say this is like 3 or 100, then I guess you can say, well, this interval to this maximum index, we sweep this like this and we're always good because there's always a wall to protect us, and then we're kind of guaranteed that this is scooped. And likewise from here to here, we just kind of reverse the indices, and then we make another pass here, and then we add the 1 properly. Because then this barrier is always high. But what if you have multiple maxes? Then which one do you choose, for example? If you have multiple maxes, you still miss this one. So would you say, I just pick any, like it's this, let's say this was 3, this was 3. You just pick whatever, one of them. And this goes here, and this goes here. Okay. Yeah, actually. If this is bigger than the maximum number, then we update the maximum number to this, and our max index is just gonna be I. And then in the end, we'll just pick one of these. And then likewise, second pass like this. So let's say 0, 1, 2, 3, 4, 5, 6, 7. Then this will go to 7. Then we're good. And then this one would go to also the 7. So let's go to max index. So let's say -1. So 6 would exclude 6, I would guess, and then it would just end up here. And length height -1. And then this is just the second pass. And then if height of I is greater than or equal to, so now I also need to reset the pointer as equal to length of height -1. So if, so the next iteration I is here. Height of I is less than, right? Not greater than. Because if I is greater than, then we don't trap anything. It's only lower than. So it's a bug there. So here, if I is higher than that, then actually no. Yeah, if it's higher than this, then we don't do anything, and if it's lower than it, then we sum up this height of pointer minus height of I, and then we go back here, and then we trap the water all the way until the max. We don't have to reset water trapped, because water trapped accumulates it like this. So return water trapped is what I'm thinking. There may be a corner case in the second one, let's see. Booyakasha. First try. Hard question. See you in the next one.